A piecewise function is an example of a function where we have different equations for different values of the independent variable or for x. So, a real life situation, now this is kind of old, so back in the day when we were first introducing cell phones and you wanted to text, you would pay per text message. You would pay a charge per text message before most places offered unlimited texting. So, in this old way of looking at it, the phone company says, well, you're going to pay $20 a month, and that is going to buy the first 60 text messages, right? So, $20 a month buys those 60. Then, each additional one over that, you're going to pay 40 cents for every text that you send after your first 60. Okay, how can we represent that? So this is how this is represented in what's called a piecewise function. So notice the bracketing here. This says that the cost to you as by the number of texts is if you have anything between 0 and 60 texts. So this over here is the independent variable, the number of texts that you sent, anywhere from 0 up to 60. What is your overall cost going to be? $20. But if you send more than 60 text messages, then we're going to take the number of texts that we sent and plug it into this equation, and it's going to end up costing us more. So let's look at an example of how we would use this. What if we wanted to find C of 30? Well, you're going to start over here on this side of the equation. 30 is between 0 and 60. So that says I am going to use this equation to answer the question, what is C of 30? So if I only send 30 texts, then I'm going to pay that flat $20. But what about C of 100? What if I sent 100 texts? Well, now we can see that 100 is in this group. It is a number of texts greater than 60. So we're going to take that 100 and plug it into this equation. So 20 plus 0.40 times 100 minus 60, what is my overall cost going to be? Well, that's going to be $36 because I did more than 60 texts and I paid that 40 cents per text. All right, now the hardest one is often the one where it breaks. So notice how 60 is involved in both of these. So what would C of 60 be? Which equation should we work in? Well, this is where we have to pay attention to the less than or greater than or equal to's. So as long as you're up to and including 60, we're going to be okay. So you can send up to 60 texts and it's only going to cost you $20. So we would plug into that first equation. So this was a real life example, but most of the time when we're in pre-calculus and further on in calculus, we're going to see examples that look like this one. Let's look at g of x. So notice we're going to use the equation negative x minus 5 as long as x is less than negative 5. And we're going to use the equation x plus 5 when x is greater than or equal to negative 5. So you can see the comma here that separates the equation from the rule, right? So let's look at our examples here. G of 0. Is 0 less than negative 5? No, so we're not going to plug into the first equation. Is 0 greater than or equal to negative 5? Yes, so we're going to plug 0 into the x of that second equation, x plus 5, and we will get our answer here is 5. Whereas g of negative 6, negative 6 is less than negative 5. Think about your negative numbers, right? Negative 6 is smaller than negative 5. So we're going to plug into the first equation here, negative x minus 5. So what is negative 6 minus 5? Well, negative times the negative is positive, so this is going to give us an answer of 1. And again, what about that breakpoint? What is g of negative 5? Let's look at this last one. So negative 5 is not included in this first set of numbers. So we're not going to plug into the first equation, but negative 5 is greater than or equal to negative 5. So we will plug negative 5 into the second equation, which is x plus 5. So negative 5 plus 5, our answer here will be 0. All right, let's look at another one that's a little more complicated because it has 3 steps of them. So let's look at our h of x here. So notice that we'll use equation number 1 for x is less than or equal to negative 1. We'll use equation number 2 for x is between -1 and 1, and we'll use equation number 3 for all x's greater than or equal to 1. So here's the comma. These are the rules. These are the equations. That's how this works. So let's look at our first equation, h of 4. 4 is greater than 1. So 4 belongs in this set of numbers, so we will plug it into equation 3. So 3 times 4 minus 2, our answer here will be 10. H of -3, -3 is less than or equal to -1, so it's in this first set of numbers. So we're going to plug it into equation number 1, which is -3 plus 2, so we'll get an answer of -1. And then h of 0, this one kind of throws people off a little bit, so let's talk about this. So obviously 0 is between -1 and 1, so we're going to plug into the second equation. And this is something that's going to happen a lot. The equation here is just 1. Notice how there's no x's. What does that mean? It means that for any number in there, the answer is 1. So if you plug in a 0.5, the answer is 1. If you plug in -1/4, the answer is 1. So what is h of 0? If we are using equation number 2, the answer is always going to be 1. Now, why do piecewise functions exist? Well, because in the real world, equations aren't always pretty. So if you look at the equation that we have up here for h of x, this is a graph of that equation. Notice that for the x's less than -1, we have one shape, which is the x plus 2 shape. For the x's between 1 and 1, we have a second shape, that red bit. And for the x's greater than 1, we have another equation, that third bit. And they all kind of come together to make this funky looking shape that's in different pieces. Thus, it is called a piecewise function.